Hello and welcome to another video in this geometry concept series. Today, we are going to be looking at a very fundamental concept and property in triangles. Once again, we all know that triangles can have a relationship of congruency. And when we say that two triangles are congruent, we basically imply that the triangles are going to be identical to each other in all aspects. Now, there are certain sufficient conditions using which we can prove congruency, and a few of these conditions we have learned in school. One of the first ones that we learn in school, which is a sufficient condition to prove congruency, is SAS congruency. SAS stands for side angle side. Now, what side angle side means is that if in two triangles, I've got one side equal to another side, one more side equal to one more side, and the included angle between the two sides also being equal, then the two triangles will 100% be congruent to each other, 100% be identical to each other in all aspects. For example, if I've got, say, two triangles like these, triangle ABC and triangle PQR, and if I have been given information using which I can observe that AB and PQ are equal in length, AC and PR are also equal in length, and if angle A and angle P are equal, then these two triangles will definitely be 100% congruent to each other by SAS congruency, by side angle side congruency. People often mistake SAS to mean that any two sides in any one angle between two triangles, if they're equal, then the two triangles are congruent. But that is not the case. Why? Because SAS should always be written as SAS with the A between the two S's. Because only if the angle included between the two equal sides, if they are equal, only then can we say that the two triangles will be 100% congruent. What I mean is that SSA is not a sufficient condition to prove congruency. So what I mean by SSA is, let's say that between these two triangles, I prove that length of AB and length of PQ are equal, length of AC and length of PR are equal. And if we can also observe that angle C and angle R are equal, then this is not sufficient information for us to conclude that the two triangles will be congruent. If this is a relationship, then the two triangles may or may not be congruent. This is not sufficient to conclude that the two triangles are congruent. Why? Because it is no longer SAS. Now it is SSA. Now, why is it that SSA is not a sufficient condition to prove congruency? Why? Because I can have two triangles which might satisfy the SSA condition, yet the two triangles might not be congruent to each other at all. Can we prove that? Can we construct two triangles which satisfy SSA, but visually, by looking at the two triangles, we can conclude that these two triangles are definitely not congruent to each other? Let's try to do that. Let's try to prove that even though I can have two triangles which are satisfying SSA, they are still not going to be congruent to each other. So for that, what I'm going to do is that I'm going to take this triangle. Okay, let me call this triangle ABC. And let me do one thing. Let me, through this point A, drop an altitude. Altitude is a perpendicular from A onto the opposite side BC. Now let me treat this line AD as a mirror. And I'm going to reflect AB about this line AD. When I reflect AD about this line, or the side AB about this line AD, what will happen is the reflection will look something like this. Right? So when AB is reflected about AD, the reflected line will look something like this. I'll call this line AB dash. Now we know, according to a previous video on reflections that we had discussed in this very series, that when a line gets reflected about a straight line, then its length does not get altered, which means that length of AB and length of AB dash will be equal. Similarly, I can observe that angle C is an angle. Angle C is equal to itself. And similarly, AC is also equal to itself. Now, I wanted to observe in this figure two triangles. One is triangle ABC. One is triangle AB dash C. Now, between triangle ABC and triangle AB dash C, I've got one side equal, which is AB and AB dash. I've got a second side equal, which is AC. It's present in both the triangles. I've got an angle also equal, which is angle C. So these two triangles are satisfying the SSA condition. But are triangle ABC and triangle AB dash C congruent? Definitely not, because AB-C is snugly fitting inside triangle ABC, and there is still some area left within triangle ABC. So that is why SSA cannot be a sufficient condition to prove congruency. You can take any triangle, and if you draw an altitude and if you reflect one side about that particular altitude, then you will get a second triangle which will be related to the first triangle, to the initial triangle by SSA condition. But the two triangles will not be congruent to each other. And this is why SSA is not a sufficient condition for congruency. This is why the angle that we are proving to be equal in SAS has to be included between the two equal sides. But SSA can work for one type of triangle. Think which one. In a future video in this very series, I will explain which one it is. But think, apply this logic, take some time for yourself and think in which triangle SSA can still work as a sufficient condition to prove congruency. Thank you.